Hello, everyone, and thank you for the kind introduction, Joss. It's really good to be here at ESLOG 2025 and talk about the topic that I am passionate about and then that I work in, which is how artificial intelligence is going to transform automation in logistics. Now, before I do that, though, I'd like to give you some background information on myself and the institute that I work for. When I tell people that I'm from Dortmund, this is what they usually associate it with and what comes to mind. It's passionate soccer fans, Borussia Dortmund, the Signal Iduna Park, our stadium. But believe it or not, there's more happening in Dortmund than just soccer. At Fraunhofer IML, right around the corner, we're making sure that logistics processes and supply chain are just as efficient as the team of Borussia Dortmund. Our motto is pretty simple. It's 100% logistics. We do applied research in logistics, which means that we work together with industry partners on topics that they would like to do research on, and also we identify research topics like artificial intelligence and then see how they can be applied in the industry. Our projects are pretty diverse. So like I said, we do research. We support all companies of all different sizes in all different industries on what they would like to investigate on. And we also develop, be it hardware solution or be it software solution, we are able to develop them from scratch to be applied in industry then. And one of the topics, of course, that we currently are very interested in is artificial intelligence and how it can be applied in industry. So, how many of you have seen an image like this before? Raise your hands if you have. All right, I'm glad the reference works. So, there was a time a couple of weeks back where you couldn't open LinkedIn or X without seeing another person's action figure being displayed on your feed. And while you may think of this trend what you like, the technology behind this is actually pretty impressive. So I created this image with just uploading a picture of myself and then giving some additional information on what I like to do. In my case, it's CrossFit. And then the ChatGPT was able to create an image like that in just a couple of seconds. So there was no human involved in creating this image other than me typing in the prompt. No 3D designer, no animator or anything like that. So we can see that this is an area where artificial intelligence already works pretty well and where we can get a lot of efficiency benefits from it. And technology doesn't stand still. What was recently just a static image can now be animated, also within just a couple of seconds. And all just based on a prompt that I entered into an application. And what you can see here was unimaginable just a couple of months ago. So we can see there's rapid progress going on in the area of artificial intelligence. And I brought just some of the milestones that we have reached in artificial intelligence in the last year alone. In May 2024, so 1 year ago, OpenAI's multimodal GPT-4o came to market. And it was their very first model that was able to handle multiple models in just one neural network. What does that mean? It means that one neural network is able to process text, images, structured data, unstructured data like Excel files or something like that, all in one neural network. And that was pretty impressive because this just happened 1.5 years after their first model, GPT, was accessed or open to access by public. In August 2024, we then had the EU AI Act come into force. And this is just one sign of governments now stepping up on artificial intelligence, not just with regulations, but also with impressive funding, right? So the EU pledged 200 billion to be invested into artificial intelligence. In the US, we have Stargate, which is to be around 500 billion US dollar. So we can see that not only regulations are coming up in artificial intelligence, but also there's very much funding in it as well. In November 2024, then Anthropic released the MCP, Model Context Protocol. Why is that so important and why is that so impressive? It's because it's the Model Context Protocol basically works as a USB-C for generative AI models, for large language models. So now it's a standard way to connect your content systems to large language models. And it means that you can just switch out whatever model you want to use to your content systems, and in that way have development speed up even more, or applications come up even more within industry. Then in March 2025, so this year, another very impressive innovation hit the market, which is the Manos AI agent. And what the Manos AI agent is and how it works, we are going to see a little bit later in this presentation as well. And then another big announcement came, which is from the area of humanoid robots. And it is that Figure AI announced that their model Helix is going to be able to do household tasks pretty soon and hit the market pretty soon as well. Together with a lot of announcement on there's even more computing capability coming up from big graphic cards manufacturers like NVIDIA, and so on, we can see that the world of AI is moving really fast. So what's going on in the area of automation? There are exciting automation solutions as well that hit the market pretty recently, and these are just some of the examples. What we can see in the area of automation is that we're moving towards increasing autonomy. And the reason for that is that we see benefits like scalability, flexibility, even sustainability, because now you can scale up your system to the demand that you currently have. And while all of these automation solutions are really exciting and impressive already, the reality is that logistics systems still often look like that. So whenever we have deviations in our processes, whenever there's unstandardized goods, or we have processes that change pretty rapidly depending on the customers that we serve, we still rely on manual work pretty heavily. And this can be in the area of physical material flows, but it for sure can also be in the area of making decisions and controlling our logistics systems. The fact is that a lot of logistics processes today still rely on manual work. So the question arises, how can artificial intelligence that has been making such great progress during these past years and showing human-like intelligence, sometimes even superhuman-like intelligence, help us to get to the future of automation in logistics? To answer this question, let's have a look at what AI applications in logistics look like today. And to make sense of the very many different ways that AI is being applied in logistics and in automation today, I'd like to introduce a simple matrix. Here you have the hierarchy level of the logistics system on the y-axis. And it goes from robotics and sensors up to shop floor and road, which is basically where humans interact with the technology. The company level, and then also the supply chain level. On the x-axis, you can see the AI capability being placed. And what do I mean by AI capability? It's basically how dependent an AI system is on human input. So the AI applications that we see in logistics today are a lot of the very specific solutions that are there to solve some very specific tasks in logistics and are pretty dependent on human input still. They vary throughout the entire hierarchy levels that we have in logistics, from robotics up all the way to supply chains. And I have brought 3 of them here today to show you what I mean with these specific solutions. So the first one is an automation solution by Boston Dynamics, which is the Boston Stretch. It is designed to automatically unload containers of boxes and packages. And the impressive part about this is that the Stretch does not need to know about the packing scheme of the containers beforehand. It doesn't have to know about the dimensions of the boxes or the color or anything like that. It works on computer vision, which means that it drives into the container, takes pictures, and processes the pictures in order to understand where to grasp the boxes and how to unload them. And this way, it is able to automate a process that so far has been manual work. So far, people went into the containers and unloaded them themselves. And artificial intelligence now makes it possible, by smart integration with automation technology, to automate this process entirely and basically just drive the robot into the container and have it being unloaded. Another example that I brought here for a specific AI solution is also from the area of computer vision. This is a solution that we have developed at Fraunhofer IML, and we're still developing. What you see here is the current status, where we have prototyped the solution in a simulation environment for rapid prototyping. And it's a solution where we use camera images in order to create a real-time digital twin of a yard system. Of course, it can also be translated to intralogistics, but currently we're focusing on the yard. So the way that it works is that there's multiple cameras that cover the entire area of the yard, and the information on the trucks that enter the yard and then drive through the yard is being handled by multiple cameras, but all combined into one data model. So basically, a truck enters, is being identified, and afterwards the information is given from camera to camera or combined in the central model. And this way you will always know where which truck is at which gate, and create transparency throughout your entire yard process by just having cameras in your yard without having to identify a truck or something like that, or any sort of vehicle on any of other points in your system. And we're currently working on transferring this from the simulation environment, where we already saw that with virtual cameras it works pretty well, to an actual yard where, of course, you have more variables like lighting throughout the day and the night and things like that. The third application for AI in logistics today that I brought is a pretty common one as well. It is forecasting. So by being able to have intelligent forecasts that are not only based on historic data, but are also based on, economic data from specific industries, or weather data, or traffic data, and so on, and having these forecast models being smart enough and more precise than current models, you are able to then make better decisions based on these smart forecasts. What you can see here is Omnistics, a platform that we are currently developing at Fraunhofer IML that is targeted towards small and medium-sized companies that are not able to develop models themselves or that do not have the expertise and know-how on how to do this. And yeah, basically you can upload your data here, your historic data that you would like to make forecasts on, and then select different external impacts that you would like to include into your model, train your model, and then make smart forecasts. And this can then be used for optimization, for example, on making decisions on resource planning or on production planning or on pricing, on planning how many vehicles have to leave when, and things like that. So basically, the AI capability here is in the forecast, and the decision based on them can be classical methods like operations research methods. So based on these three examples, together with the applications that we all probably know by now, like ChatGPT being able to analyze documents and things like that, these specific AI applications are still very dependent on human input, and they can be categorized into three categories, which is basically perception AI, everything that has to do with cameras or document identification, predictive AI, which is everything that has to do with forecasting, and generative AI, like I said, generating texts, understanding text, and things like that. So these are the solutions that are pretty common in logistics currently. Where are we currently going? Where is this development going? And what we see is, in AI, the same thing is happening that is happening in automation as well, which is a move towards more autonomous AI systems. And I have talked about the Manus AI agent before, which is a pretty good example on what is happening if we give more autonomy to AI systems. Here, the example is that this is a video that you can also see on YouTube from Manus AI, which shows how their AI agent works. Basically, you have a chat interface the same way like you would have with ChatGPT, and you give it some specific task to solve. In this case, it is to do research on properties to purchase in New York. And you give some background information on what you would like this property, or characteristics that you would like this property to have. What happens then is that the agent is able to create a to-do list itself on how to do research on this topic. It is able to access different tools on your computer, like a browser or maybe like IDE to write code. It can write Python code, it can then execute the code, and it can gather information through all different kinds of tools and resources, and in the end compile a comprehensive report for me in which it basically combines all of its findings that I can then read, and I have gained efficiency because I didn't have to do the research myself. So, with this development happening in AI currently, we can see that also for logistics, we're moving towards more autonomous AI solutions. And these are just some of the examples that you could think of for agentic AI solutions. And in order to make it more clear, I'm going to show another example of one, which is something that we're looking into right now. It is an agent to design warehouses for us. So warehouse design is the area that I usually work in. And the idea would be that an agent is now able to support me in doing my work. And how does it do it? An AI agent is based on large language models as well, so it does have the foundation of a world model. It has basic intelligence and can do reasoning, so it does have reasoning capabilities. And together with domain knowledge, so knowledge that I would have to give the AI agent on how to actually design warehouses and how my process would be, I could then give the agent autonomy in order to access different tools that I would usually use, which is Excel, AutoCAD, maybe Blender if I want to have a 3D image of my warehouse. I can give the agent access to my data, to a history of what I have planned in the past, and I can give it some goals that I want it to reach with my task with creating the warehouses. So do I want it to be fully automated? Do I want it to have low cost, low investment cost, low operation cost, and things like that? And then, just like the Manos AI agent that you just saw, it can create a task list on how to access which tools, which data pools, and so on, and then create a couple of different designs for me that I can then choose from and say, okay, this one looks good for the restrictions that I have. So basically, it still involves humans to make the decision in the end, but we are able to get a much deeper decision basis from the AI agents, and we do not need to do a lot of the works ourselves. So this means we're currently in the wave of agentic AI. If agentic AI is happening right now, what can we expect to happen next? And the next wave of AI is predicted to be physical artificial intelligence. What does that mean? It means that we are going to combine digital intelligence together with the ability to physically act out our decisions. The difference to AI agents is also that the physical AI models are based on data from the actual real world, because if you think of large language models right now, they're based on knowledge from the internet. But they do not have knowledge about our actual physical world where they would act together with us, like spatial understanding, for example. So with physical artificial intelligence, we're going to create artificial intelligence models that enable robots or technology to act in the actual real world as well. And since real-world data also is limited, those models will often be created in combination with simulation environments, like the one that you can see here. Simulation environments that are able to capture the real world or to have the same physical elements that the real world has, like this one here is NVIDIA Omniverse, but there's also, environments like Unity or something like that. If we train our models in these worlds, we're able to transform the knowledge into the real world as well, as you can see here. The model that here is trained to grasp the screwdriver has been trained in a simulation environment, but we can actually act out the performance in the real world as well. And if we're thinking this together with humanoid robots, it opens up completely new fields of action. What you see here is Figure AI and their model F02. That has been deployed to logistics processes. BMW actually just did a test with them in one of their factories. And if we combine these humanoid robots that are now already able to do, sortation tasks or tasks like placing items into machines, and we combine it with general artificial intelligence that we have in our digital world, we can then create humanoid robots that are not only able to do one task that they have been trained for, but to do multiple tasks and to be robust to new tasks, like humans are in the real world. So to answer our questions, how can we use AI to make the leap into the future? AI is going to make the difference when it comes to increasing autonomy in automation solution and handling complex environments that we see in logistics. We will still see, though, that this is a transformation process. So there's going to be more and more specific AI solutions that we see in industry. We're going to see more and more agentic AI solution being integrated into our automation technology. And if we have learned one thing from digitalization is that we have to work for a transformation process like this. So it's not just going to happen by itself, but we're going to have to put in the work in order to create the future of autonomy and automation in logistics. One thing that I would like to stress, though, is that the human factor will still continue to play a big role in these systems, though, for a very long time. Because error handling and things like that, those are aspects that are pretty hard to automate. So in conclusion, where is the true value of AI in automation? It's where automation or autonomy only becomes possible because of AI in these complex environments and changing environments that we have in logistics. And it is where humans and AI are not competitors, but where humans are freed up to perform higher dimensional tasks. Basically, work together with AI, be supported by AI, but still have their own area of expertise. So finally, I'd like to leave you with this very last message. You never walk alone. So if there are some hesitations or if there are some reservations or questions on how to start with an AI journey in logistics, I can tell you you're not alone on this journey. There's organizations like Fraunhofer IML who are more than happy to work with you on this journey and to support you every step of the way. So I'm happy to discuss possible starting points during the break. Thank you.
Great, thank you. Thank you very much. We do have some time for some questions. If you have them, you can go into Slido. Interesting, I noticed in Slido that you can even use AI if you want to improve your question or shorten it. So even Slido has, AI has come to question asking at congresses. So we've got the first question here. You mentioned a lot of solutions that are being offered, but which companies are actually using them? Do you have any examples of companies that are all in? And on the other hand, are there companies that are still resistant that you say, well, it's a pity they should be doing more?
Yeah, so I can answer this question from a German standpoint. We do have big logistics service providers that are partners with us in our enterprise labs. And these big companies like Rhenus, Schenker, Daxa, they are all very interested in AI solutions and how to incorporate them in their logistics worlds. We do find, though, that small and medium-sized businesses usually have hesitations or do not know where to start with their AI journey. So those are the companies that are pretty reliant on application providers on the market and on support from companies or organizations like Fraunhofer IML, where we work together with them on creating solutions that can then be brought to a broader audience. Also, one thing that is a pretty interesting development in this field is open source. So we can see that even though we do have big companies in Germany, they're not as big as, Meta or Google, and they cannot create their own models. So what they do right now is they cooperate to create open source solutions and then to a specific point, and then based on them build their own USPs.
Okay, great. One more question. We have here, in what part of logistics processes will the implementation of AI be the most complicated to implement?
Well, what we see currently is mostly perception AI, right? And generative AI, so it's where we take information from the real world and then use AI in order to help us digitalize them, get a digital image of what is happening in the system currently. So where it is really difficult to implement is the further up you get into the hierarchy of logistics systems, because then you have difficulties with data availability, trust issues when it comes to supply chain cooperation use cases. I talked about that, quality of data. So basically, the further up you get into the decision-making hierarchy of logistics systems, the more difficult it gets.
Good. So yeah, I'm asking about your movie taste. Are you a fan of the Terminator movies? But I think I know what they're getting at. I mean, do you see?
It's true.
Are you scared at all about what's happening with AI?
Well, for me in logistics, the scary part of AI for me is not in logistics, let's put it that way. And there is a lot of benchmarks that are coming up right now that are used to test reliability and trustworthiness of AI systems. So research is big on making sure that we can trust the AI solutions that are currently being developed. And this is a development that makes me not so scared about the future of AI.
Yeah. Okay, good, good. I think these questions are going to keep on coming, and the discussion is great. But unfortunately, we have to move on with the program. But Anike will be available for you during the coffee breaks, and so you can grab her and answer she can answer the rest of the questions that were provided. So I'd like to thank you very much, Anike, for a great presentation and for coming all the way to East Log. And good luck in all your travels and all your presentations at other conferences as well. Thank you.
Let me give this back to you.
Yes. More important than AI is the clicker at the conferences.